Here's a tutorial for linear combination. So linear combination is also called the elimination method when you have a system of equations. So the goal is the goal of doing linear combination is so that when you add and subtract up and down, that one of the variables will cancel. So in order to make that happen, you need the coefficients of the variables, the number in front of the letter, to be the same number opposite sign. For example, if you had 2x, then you would need the bottom guy to be negative 2x. And so you achieve that by multiplication. You would multiply either the top equation or the bottom equation by a number so that the coefficients would result to be the same. So it could be that you may have to multiply the top guy, you could have to multiply the bottom guy, or you could have to multiply both. Or in this case, you could simply just add and subtract up and down. So one of the first things I check with linear combination is if I were to add up and down, would anything cancel? Well, I notice here x minus x, that would cancel. Negative 2y plus 3y would be y. And then 6 plus negative 4 is 2. So notice here the x values cancel, and I end up with y equal to 2. If y is equal to 2, then I'm able to then take that value and plug it into either equation, and I should be able to solve for x. So negative 2 times 2 is negative 4, and then I would add 4 on both sides. I'd end up with x equals 10. And also, if you look at, if you plugged it into the second equation, you should get the same answer for x. Notice that the x value is the same. We still end up with x equals 10. Okay, for this problem, we're going to do the linear combination method. So what we're going to do is we're going to eliminate the x. So notice the coefficient of the top equation is 5. Notice that the coefficient for x for the bottom equation is 2, and 2 does not go into 5 without a remainder, and 5 doesn't go into 2. So what I end up doing is I multiply the top equation by 2, and I multiply the bottom equation by 5. Now notice that the original, the 5x and 2x, are positive, so I need to make one of them negative. Doesn't matter which one, I'll go ahead and choose negative 2 to be negative. If you chose the 5 to be negative when you multiply, you should end up with the same answer. If I were to distribute, I end up with negative 10x minus 6y is equal to 18. And then the bottom would be 10x minus 25y is equal to negative 80. And then once I distribute, then I'm able to add up and down. And I notice I end up with negative 31y is equal to negative 62. And then from there, I divide by negative 31. I end up with y is equal to positive 2. Now, we can do what's called double elimination. So first I eliminated the x. Now I can eliminate the y. Notice that the 3, it's positive 3y and negative 5y. So there's already been, the signs are already different. So I simply would multiply the top equation by 5. Because 5 and 3 have nothing in common, I multiply the bottom equation by 3. When I do that and distribute, I end up with 25x plus 15y is equal to negative 45. And then 6x minus 15y is equal to negative 48. Then you add up and down, and you end up with 31x is equal to negative 93. Then to solve for x, I divide both sides by 31. I end up with x equals -3. So my answer would be x equals -3, y equals 2. X equals -3, y equals 2. Okay, here's another problem. If I did the elimination method and I wanted to eliminate the x, notice that I have 12x and I have -6x. So I simply would multiply the bottom by +2. So I end up with 12x minus 13y is equal to 2. And then -12x. And then 6.5 times 2 is 13. And then 2 times -2 is -4. And then again we add up and down. So I do that. Notice the x's cancel and the y's also cancel. So I have 0 is equal to -2. Now, if the variables cancel in a problem and I'm solving, if the left side and the right side are equal, then my answer is infinitely many solutions. But in this case, because it's 0 equal to -2, my answer would be no solution. So in this case, for the last one, the lines are considered parallel, but they don't intersect because you have the numbers aren't equal to each other. That's why we say there's no solution. Now we'll give one where the other instance where you end up with the number equal to the same number. Okay, so for this guy here, you would multiply the bottom. If I'm trying to eliminate the x, I'd multiply the bottom by 3 because 4 goes into 12 3 times. I end up with 12x minus 3y is equal to +6. And I have to multiply, by -3. When I distribute, it'll be -12x plus 3y is equal to -6. Notice that when you add up and down, you end up with 0 equals 0. Okay, so if the number is equal to the same on each side, in this case 0 equals 0, we know that they are parallel lines. Okay, and because they're equal, we know they're actually the same line, meaning that if you plug a corresponding value, any value of x that works for one will work for the other. Any value of y that works for one will work for the other. So that's linear combination. You have where you first add to see if it cancels. If it doesn't cancel, then you find out what you need to multiply by in order to get the coefficient, the numbers in front of each variable to be the same but opposite sign. So you multiply to get the coefficients the same but opposite sign. Then the third thing you do is you add up and down. You add up and down, and then after that you solve for the variable. And then when you're done with that, then you plug that answer. You do the same thing for the other variable. So if you eliminate x first, then you go back and you do the same steps to eliminate y.